All right, this video will be the first 4 sections in this packet, so the first half of the packet. And these are, this is called rectilinear motion. You're moving on the rectangular plane, just left and right. But these are also called parametric equations, which is something we study in our very last unit. But for now, you can start with parametric equations where time is the parameter, and it just controls something that's either moving left and right or up and down. At the end of the year, we'll have particles that are moving on curves. Okay, find x of 0. So this means when t is 0, what position is the particle falling under on the x-axis? So at t equals 0, we're sitting here at -2, and this is feet. When time is 3, where is the particle? The particle is at -4 feet. Find the change in position from 0 to 3. So get in the habit of writing formulas out for this. Every time I see change in position, I'm going to show myself that in this case, that's the position function is x of t. So that's going to be x of 3 minus x of 0. It's always the later time minus the first one. So that's -4 minus -2. So that's a change of -2 feet. And if you look at the picture, all that means is compare the particle's position at 0 and that at 3. At 3 seconds, the particle is 2 feet to the left of where it was at 0. Is the velocity positive or negative at t equals 1/4? Remember, velocity is slope. Now, slope is tricky because we're looking at this thing moving left and right, but it also indicates when a function is increasing. A slope is positive if a function is increasing, and the horizontal position is increasing on this interval. So I'm going to write it like this. V of 1/4, the velocity at 1/4, is positive, greater than 0, because the position, x of t, is increasing. At t equals 2 3/4, what's happening? So at 2 3/4, you're on this section down here between 2 seconds and 3 seconds, and the particle is moving to the left that entire time. So I'm going to say v of 2.75, 2 3/4, is less than 0, negative, because x of t is decreasing. And the way I'm writing everything, by the way, is what I would write if these were AP exam questions. So this is enough justification. It's clear, it's concise. They're not looking for an entire paragraph. Average velocity is defined as change in position over change in time. So we're going to write this formula every time with just numbers filled in. So find the average velocity from 1 to 2. So that's going to be x of 2 minus x of 1. That's what I mean by filling numbers in, over 2 minus 1. X of 2, the particle's position is 4, minus x of 1, the particle's position is 2. 2 minus 1 is just 1 second. So the average velocity is 2 feet per second. Find the average velocity from 0 to 3. So again, show your work. You would need to do this for the AP exam too. X of 3 minus x of 0 over 3 minus 0. So x of 3 was -4 feet minus -2 feet all over 3. -4 plus 2 is -2. So that's -2/3 feet per second. What is the total distance traveled? So total distance, I always put absolute values around this phrase to remind myself. Total distance doesn't care about whether you're moving left or right. So I think of it as just absolute, take the absolute value of everything. So how far has this thing traveled from 0 to 3? So from 0 to 2, the particle goes from -2 to 4. So that's 6 feet total that it traveled. So you're starting with 6. And then add to that, the particle goes from 4 to -4. So that's a total of 8 units. It doesn't matter that it's to the left. That's just a distance of 8 units. It's like if I ran 6 feet down the hallway and then I turned around and ran 8 feet back to the hallway, I ran 14 feet. That's what we're saying. So this is 14 feet for this particle. Average speed is defined as total distance over total time. So that means that we're taking our total distance, which we just found, 14 feet, and we're dividing it by the total time that passed. 3 to 0 seconds is 3 seconds. So that's 14/3 feet per second. That's the speed, average speed from 0 to 3. All right, question 2. A particle moves right and left along a horizontal line. Its position in inches is defined in terms of seconds, shown on the graph. So this is different than the first graph. Instead of showing you horizontal lines stacked on top of each other, the vertical axis represents x of t, the horizontal position, and then the horizontal axis is t. So find x of 2. That just means go to 2 seconds and figure out what this point is. Well, this is on a line, so even though it's not showing me what that point is, this slope is, down 1 over 2. So if I'm at 2, I should be halfway between 3 and 4, right? So that should be at 3.5 inches. Now, if this were uglier, if it were not just a half, you could do, figure out the slope. Again, the slope was -1/2. You could do a little point slope formula to figure out an equation for that line. And then you could plug in when t equals 2, what is the y coordinate? Okay, anyway, find the change in position from 1 to 5. So x of 5, always write the formula, minus x of 1. X of 5 is 5. X of 1 is 4. So change in position is 1 inch. That just means when the particle is sitting here at 5, it's 1 inch to the right of where it was when it was at 1 second. Find the change in position from 3 to 7. So that's x of 7 minus x of 3. X of 7 is -3. X of 3 is 3. So -3 minus 3 is -6 inches. So the particle is 6 inches lower than it was down here compared to here. Find the total distance traveled from 0 to 7. Okay, so I'm going to take this on each little line segment. So what's the change in position here? So from 0 seconds to 1 second, we went from 1 to 4. So we start off increasing by 3. We're going to add to that. It's a decrease of 1 inch, but I'm just going to add 1 inch traveled. And then I'm going to add 2 inches traveled on this third segment from 3 to 5. And then I'm going to add from 5 down to -3. That's 8 inches traveled. So this is a total of 14 inches traveled from 0 to 7 seconds. Find the average velocity from 1 to 5. So remember, that's change in position from 1 to 5 over change in time. So that's x of 5 minus x of 1 over 5 minus 1. Now we did already find the change in position from 1 to 5. It was 1 inch over 4. So 1/4 of an inch per second. During which intervals is the velocity negative and why? So I like to give my justification first and then the answer because it helps me work through what I should be looking for. So the answer to when is velocity negative will always be when the position is decreasing. So v of t is less than 0 when x of t is decreasing, right? Because the slope is negative if the graph is decreasing and velocity is slope. Okay, so when does that happen? So that happens on interval, there's 2. So on the intervals 1 to 3 and 5 to 7. If you're going to use interval notation, it's a good idea to write the answer on intervals this and this so they don't look like just ordered pairs. Or you could say 1 less than t less than 3, 5 less than t less than 7. And during which interval is the particle traveling the fastest? Now, fastest is talking about speed, not slope. So, or I'm sorry, speed, not velocity. So not the slope. We want the, Let me try that again. So we do want the slope. We want the steepest slope. We don't care about positive or negative. We just want the steepest, the most distance traveled over an amount of time. Okay, so we have a slope of 3. We have a slope of -1/2. We have a slope of 1 right here. What's this slope? -8/2, so -4. So this is definitely the steepest slope. So the particle travels the fastest on 5 less than t less than 7. At what time was the particle furthest to the right? We're still talking about here. So you can kind of turn this graph on its side and say, okay, the particle traveled to the right, then it went a little bit left, and then it went really far right again, and it never went past that point. So at what time? That was at t equals 5, because then it only goes left from there. So at t equals 5 seconds. Draw velocity versus time graph. So remember, velocity is the slope, and this is a linear position graph. So we're going to have all these little horizontal lines. It was good that I wrote the velocities out before. So we have a slope of 3 for times between 0 and 1. So on 0 to 1, I'm going to draw a horizontal line through 3, and it should start and end with open circles, because at these starting points and turning points, the velocity is not 3, nor is it -1/2. It has a turn there. Okay, so then the slope is -1/2 between times 1 and 3. And then the slope changes to 1 between times 3 and 5. And then the slope ends at -4 between times 5 to 7. And 6 is included in that, so we don't need to break it up at 6. So from 5 to 7, we're at -4. It would be wrong to put an open circle at 6 because the slope is -4 at 6. It's not excluded. Okay, section 3. A particle moves up and down along a vertical line. Let y of t represent its position in centimeters, and t is in seconds. And this is a velocity graph. So when I have a velocity graph, I like to remind myself just by putting like a big plus and a minus here. We are given a position. We don't need that for now. We're given a position at y of 0, we're at 2. This says find v of 3. So that just means on the velocity graph, when the time input is 3, where do you fall? You fall at -2 centimeters per second. Okay, find the change in position from 0 to 1. So this is kind of a nice trick. If you're given a velocity graph, to find the change in position, you can always find the area between v of t and the horizontal axis. And I'll explain why that works in a minute, but let's find that area first. So from 0 to 1, if I were to connect this back to the horizontal axis, I get this little rectangle, right? So what is this area? Well, it's got a base of 1 and a height of 3. So the area there is 3, but what are you really doing? You're actually multiplying. A base of 1 means 1 second, and a height of 3 means 3 centimeters per second. And if you multiply centimeters per second times seconds, this takes you back to your chemistry days probably, you're left with centimeters, right? So the reason you can find the area underneath a velocity curve is because you will only be left with a position function. Or if you had Physics C last year, you might remember when you integrate, we'll talk about this later, but when you integrate velocity, you get back to position. All right, so our answer is 3 centimeters. And because I know the change in position and I know the starting position, I can find the position at 1. Y of 1 is equal to the starting position, y of 0, plus this change in position from 0 to 1 second, so plus 3. Y of 0 is 2, plus 3. So y of 1, the position at 1, is equal to 5 centimeters. Find the change in position from 0 to 6. So we did 0 to 1, but again, connect velocity back up in this case to the horizontal axis. So what is this area? Well, we have a base of 3 We have a height of 2, so this would be -6. And what would this little area be? Base of 2 times a height of 1, so +2. So we have change in position from 0 to 6. We start with 3, we subtract 6 from that, we add 2 to that. So the particle goes up 3, down 6, up 2. So that's -1 centimeter is the change in position. So find y of 6. Well, again, we always go back to change in position from 0 to 6 is -1, so it should be the starting position minus 1 centimeter. So 2 minus 1 is +1 centimeter. So we're sitting at 1 centimeter at 6 seconds. Find the total distance traveled from 0 to 6. So total distance traveled, remember, is just absolute value. So we went 3 centimeters, and then instead of -6, I'll say plus another 6 centimeters, plus another 2 centimeters. That's 11 centimeters traveled over that time span. At what time was the particle furthest upward? So kind of what we're doing with this position. So the particle starts at 2, right? And then it goes up 3. So now you're at 5. And then it goes down 6. So if you're at 5 and you go down 6, now you're at -1 here. Right? And then after that, it goes up 2. So if we go up 2 from -1, we're at like 1. I didn't scale this very well. So furthest upward was that initial up. It never really recovered from that and got any higher. So at what time does that happen? That's at t equals 1. When it finishes traveling, it's 3 centimeters. Furthest downward, it was when it hit -1. So when it finally at 4 seconds is when it finishes its -6 there. So that's at t equals 4. And then draw a position versus time graph. So we were told that y of 0 equals 2. So we start there, 0, 2. And then remember, use these changes in position. So at 1 second, you should go up 3 units. So at 1 second, go up 3, and you're at 5. Okay, and then after 4 seconds, you go down a total of 6. Or when you get to 4 seconds, excuse me, you go down a total of 6. So you should be at -1 at 4. You can also do this if you want to be a bit more accurate. The slope there is -2. So from here, you could say go down 2 over 1, down 2 over 1, down 2 over 1. That lands me in the same spot as well. What was the slope for the last bit? Slope is 1. So up 1 over 1, up 1 over 1. Also, you should land at 6. If you add 2, you should land at +1. Okay, last problem here. The graph below illustrates motion along a horizontal line. So this is back to a position graph. What's the particle's position at t equals 0? So I'm going to just estimate and assume this is 30 meters. What is the particle's position at 5? That looks like it's supposed to be 40 meters. During what time intervals is the particle moving to the left and why? So I know the particle is moving to the left when the position is decreasing. So when s of t is decreasing, when the position is decreasing, particle moves left. So what time intervals does that happen? There are 2 of them. So we've got on the intervals 0 to 4 and 5 to 8. Parentheses for all of these because the turning points don't count as increasing or decreasing. What is the average velocity from 4 to 8? So instead of x, this is called s of t. So it's going to be s of 8 minus s of 4 over 8 minus 4. S of 8 looks like it's at -80. S of 4 looks like it's at about 10. That's a difference of 4 seconds. So 90 divided by 4 is 22.5, or negative 22.5. Or you could say, what did I say, 90 over 4. So you could say negative 45 over 2. That's fine. Meters per second. Make sure you have the negative on there. During what time interval is the velocity the greatest? So velocity the greatest. We have this question in pre-calc sometimes. If I were making a velocity graph, I'm not talking about the steepest slope. I'm talking about the highest positive number. Highest positive number. There's only one positive slope here. So on what time interval is the velocity the greatest? It doesn't matter that there's a steeper slope out there. It's just what's the highest positive number. So that's on the interval 4 to 5. During what time interval is the particle's speed the greatest? This one is about steepest slope. I always think of this, I know it's not exactly correct, but I think of this as like, when am I hitting the gas the hardest? Am I driving fastest forward or backward? It doesn't matter. My speed was the greatest if I was going, it could be the greatest if I'm going backwards. So it's definitely not this slope. Let's compare these two because they look kind of similar. We go from 10 to 40, so that's a slope of 30. This one goes from 40 to 0 in 1 second, so that's a slope of negative 40. So that's the steeper section. Okay, so that's on the interval from 5 all the way to 8. So steepest slope is 5 less than t less than 8. What was the change in position from 0 to 5? So that's s of 5 minus s of 0. S of 5 is 40. S of 0 is 30. So 40 minus 30 is a change of 10 meters. What's the total distance traveled from 0 to 5? So total distance is saying, all right, we went from 30 to 10. So that's a change of 20. And then add to that a change from 10 to 40. So you're adding 30 to that. So that's a change of 50 meters. Draw a velocity versus time graph for the particle. So remember, velocity is just saying slope, right? So the first slope, what is this slope? We go from 30 to 10. So that's down 20 over a span of 4 seconds. So that's a slope of negative 5. So the first slope between 0 and 4 is sitting at negative 5 right here. And then the slope goes to 30, just between 4 and 5. So open circles on the ends of these, horizontal lines, that's supposed to be open. Sorry, that's not quite clear. There we go. And then we had a slope of negative 40 from 5 to 8. So open circles to end that there. Okay, so that's the end of this first section. My next video will do the last half of the packet.